So again, my name's Jason Klein, and tonight we're going to be talking about cloud networking for developers. Here's some of the different terminology that we're going to cover. Everything from VPCs and subnets to different types of gateways, IP addressing, DNS, load balancers, and the related target groups and SSL certs. How many of you have deployed any type of services on AWS? Okay, so over half. That's awesome. How many of you feel like you're a rock star at AWS networking? You're in the right place. We'll get you taken care of. And now, how many of you have a networking background of some sort? Okay, so it's just a matter of bridging those concepts over to the cloud. Well, I should be able to help you out with that too. We're gonna start at the basics, and I lied. I might go ahead and hop over to the console just so you can see where some of these things are, since some of you don't have much cloud networking experience at all, just because I want you to know where to find these things. But we're gonna start by talking about virtual private clouds and subnets. So when you're building out your AWS infrastructure, that could mean all kinds of things. I mean, traditionally that's meant EC2 instances, which are basically small virtual servers, but nowadays that can also include your S3 storage or your Lambda serverless functions, or even Docker containers or Kubernetes clusters. But for simplicity's sake, I'm going to focus on EC2 instances and that terminology, because a lot of that will carry over to the containers and the Lambda serverless functions. So when you set up virtual private clouds and subnets in Amazon, you're basically building out the network that is going to connect all of your resources on AWS. When you first sign up for an AWS account, you're automatically going to have a VPC and a handful of subnets. How many here have an AWS account? I'm assuming most of you, but probably not all of you. So a few of you don't, so you don't have a VPC yet. But when you first start that account, they give you some basics to work with. And a lot of people, when they first get started, they'll start spinning up resources, and all of those resources end in that one VPC. That's just one big network that's private to your account, and you can sort of control who can get in, who can get out. Subnets are, and I'm talking about a lot of this logically. I'm not going to get into the technical side of things, because I really want you to sort of understand how everything comes together, so that then when you dig into it, you can picture why things work a certain way. Subnets, a VPC is tied to one region. With AWS, they operate, they have multiple regions in the United States. They have regions all over the country and all over the world. In the United States, examples would be US East 1, their original region in North Virginia. US East 2, which is a more modern region that's based out of Ohio. And I say modern, it's technically similar to the rest of the regions. You'd see the same services, but it came online later. And then you've got US West 1 out of California and US West 2 out of Oregon. Each of those are regions. And if you decided that you wanted to deploy any services in AWS, you would end up having to deploy them to a VPC in US East 1 or a VPC in US East 2. And as you deploy that, they'll automatically roll out that network, that virtual private cloud, in each of those regions. But I was getting ahead of myself a little earlier when I said a lot of people, when they get started with AWS, they'll just start rolling out all of their infrastructure in a single VPC. And that technically that works fine, but from a best practice point of view and from a security point of view, it can be cumbersome, and it can be difficult to manage, and it can be risky from a security point of view. How many of you have worked with web applications? And I'm assuming most of those applications are database driven. So what I'll see a lot of times on AWS is that they'll roll out everything on one EC2 instance when they first get started, because they're basically doing like a forklift move over from some physical infrastructure, and they might have had a server that had Apache or Nginx and MySQL or Postgres, some stack like that on one server. And so they'll move that over, and the next thing you know, you have an instance that you're managing on your own that has all of those things. But what is more common in a cloud scenario is they'll split out the sort of public facing roles and the private facing roles. So imagine your web server, everybody has to get to that, right? I mean, unless it's some sort of company intranet, I'm just gonna make the assumption that most people are working with public facing websites. You would want that in a VPC or a subnet that's public facing, but you don't necessarily need your database and some of those other resources to be public facing. For example, let's say, let's go with WordPress stack, because Miranda and I were talking about that a little bit earlier in the other room. You could have WordPress set up in such a way that the WordPress website is running on Apache. The MySQL server could be running on a separate instance altogether that has no reason to be accessible to the internet. And so with VPCs and subnets, you could set up a second subnet in the same region as that web server, but you could set up that subnet in such a way that it's not accessible to the public. It's only accessible from the subnet that your web server is in, which means that if someone wanted to get to your data, they'd have to piggyback off your web server somehow and make another step, which just insulates that data. The same can be true of S3 buckets. You can lock down S3 buckets in such a way that people can only access them from a certain VPC. And by doing that, again, let's say using the WordPress example, you have a plugin that pushes all of your media out to an S3 bucket so that your web server isn't having to host all of the user images. Or maybe you're running a cluster of web servers and you don't want any user content on your web servers. You want them to be fairly stateless, where any of them can handle the user request, and then behind the scenes they all hit a common database server and a common storage server, the S3 service. There's really no reason for the S3 service or the database service to be public facing in that case. So I hope that makes sense. When it comes to virtual private clouds and subnets, you want to go above and beyond the defaults. You don't want to just stick with the one VPC and the one subnet per data center that they provide. If you pull up an account, though, I will show you. Let's see here. I'll log into something where I can show you a console. I went into the AWS console and then I searched for VPC. This is a default account, so it only has one VPC. But I could certainly create others, and the benefit of that is, at that point, I would, if I wanted those VPCs to talk to each other, I would have to peer them and set up some sort of routing between them. Subnets, on the other hand, this is a default account. You can see that I have a bunch of subnets, and I didn't create any of these. These represent a different data center. In each one of these is a different data center in the region. When you're looking at the top of your AWS console, you can see that I'm in the North Virginia region, or US East 1. And if you drill down to any of these subnets, you'll see it's something like US East 1A, B, C, D, E. This particular one is 1E. And the reason that they do that is when you launch services in a subnet, if all of your services are in basically subnet 1E, you know that they're all in the same data center, and so they have very low latency. So your web server is able to talk to your database server much faster if they're both in the same subnet, because they're both in the same physical building. Whereas if I were to put my web server in 1E and then I put my database server in 1A, there's no telling exactly what that distance is between the two, but rather than measuring it in feet, you're measuring it in miles. And when you have a really chatty app where it's having to talk to a database quite a bit, that can affect user experience. Now, what some people will do is they'll roll out web servers and database servers in select subnets. So maybe if they don't want a data center outage to take down their app, they'll choose subnet A and subnet B, and they'll have a pair of like a database server and a web server in A and a database server and a web server in B, and the two database servers are syncing with each other. So as long as both data centers are up, the latency between those two data centers is not really as big of a deal. It's not user facing, and so that data gets synced up pretty quickly. But if you have all of your web servers in one data center and all of your database servers in another data center, you can probably see how that could go wrong. A, from a performance point of view, but B, if the data center that has your databases goes down, you thought that you might have some redundancy or fault tolerance, and that's just out the window because that particular one got flooded or hit by a hurricane or whatever might have gone wrong. So that's what you're seeing from a subnet point of view. And now I mentioned that you can have public facing and private facing subnets. You can add above and beyond what you see here. We can go in and create a subnet. We could give it an optional name. We can choose the VPC that it's going to go into. But more importantly, we can choose that availability zone. So if we've pinned all of our resources to say I keep saying A and B because it's shorter than saying US East 1A, US East 1B. But if we decided everything's going to go in maybe a couple of those availability zones, and we do want our database servers to be in A and B, we would want to add a second, say, and the name tag is completely optional, but maybe private subnet. And then we would need to define an IPv4 block. We'll get a little bit more into addressing later for those of you who aren't familiar with that. But the idea being that you want each of these blocks of resources to have addresses that don't overlap the other blocks. And when you go to create this, by default, your additional subnets won't be public facing. They won't be accessible from the outside. But you can set up routing between them, and you can set up your firewalls in such a way that your web servers can access your database servers. And we're going to get a little bit more into that in a bit. But with that being said, before I move on, are there any questions regarding virtual private clouds and subnets? I know there's a ton of material to cover in probably not even an hour because I know we've got a late start, but I'm glad to have interruptions.
Do they charge for VPCs?
That's a great question. Do they charge for VPCs? And I don't pay attention to that. So that is either very inexpensive or they do not. Now, along those lines, that's a good segue into our third slide, which the gateways, where some of the gateways do have fees that you have to watch out for. So I'm going to cover that in a bit. But any of the VPC fees are going to be pretty low, at least from our experience. And one more aside with VPCs and subnets, if you get to where you're hosting a lot in AWS, like let's say you have enough infrastructure that you're rolling out a development environment and a production environment, a lot of people will think, oh, that obviously needs to be in a separate VPC, and you're right. But look at creating multiple AWS accounts when you get to that point. That way you can give your developers access to the developer account that has its own VPC and its own infrastructure, and then your production account can be limited to just certain people. That way if somehow you mess up your permissions and IAM, you know that you're still covered because they just don't have access to the account, period. It can prevent a lot of unfortunate mishaps. And that's also considered a best practice. And we've talked about that in the past. You could form all of those accounts under a single AWS organization to where you still have single billing. You can have shared reserved instances and things like that. So if those are some things you've seen or read about and would think, oh, that's out the window, they've actually addressed some of those things. So with that, I wanted to talk more about network ACLs and security groups. How many of you have heard either of those terms? Okay, great. Most people, I think, would have heard of security groups, but maybe not as many of the network ACLs. And the reason for that is network ACLs are applied at the VPC level, whereas security groups are applied at the subnet level. And I'm going to show you where to find each of those before I describe them, but the important thing to know about the two is when you set up security groups, you can go in and I'm just drilling down to security groups here, and I have a default security group since this is a test account. You can go into the security group, and by default it allows all traffic in and it allows all traffic out. And what you're seeing here is if we were to edit the rules and add a rule, I'm hoping everybody can see that all right. You can choose the type of traffic you'd like to allow. So let's say we wanted to allow traffic to our web server. You can type HTTP, and they already have a predefined rule here. We would probably also want to allow to HTTPS. Now, realistically, you would handle this a little bit differently because most of your web traffic is going to come into a load balancer or CloudFront or something like that. But to give you an idea, you can now it'll populate the protocol, the port range, and each protocol is going to have a different port. So if you're trying to give access to your database server, it's going to have a different port, or your mail server will have a different port. But then you can say, I want to allow HTTP or HTTPS from a certain range, and you can type in a range. So if you know my corporate network is 55.55.55.0/24, only that network would be able to access port 80 in your account. But in the real world, if you're setting up a public-facing server, you're probably going to want to allow traffic from anywhere. Now, here in recent years, they've added the ability to add a description. I would highly recommend putting a note in there, like public web traffic, just so that you know what that is. And when you only have 2 rules, not super critical. When you get to a point where you have dozens of rules and you're trying to remember what server is that or why did we allow that, that is very handy to have. So you'll notice when you set this up, you say allow traffic to port 80, and a lot of people who haven't had to deal with networking won't realize this, but the way firewalls used to work, when you'd open it up and say, I want people out on the internet to be able to access port 80 or port 443 on my web server, you would have to open up a port in so that the traffic could come in, and then you'd have to open up a port out so that the web server could reply to the user. This is called stateful packet inspection. That really just means you don't have to worry about the reply. When it sees that request come in, it can tell the web server is getting ready to reply this way, and so I'm going to allow that out because that was the reply to this allowed traffic. But the reason I bring that up is when you get into your network ACLs, which are at the VPC layer and control the whole network, they are not stateful, meaning if you get to where you're wanting to manage inbound or outbound rules, you have to be very careful to allow the reply traffic. So let's say you wanted to lock it down and you thought, geez, by default it's allowing all traffic in, and then there's a rule that follows it that denies all traffic. I mean, the first rule is going to win, so all of my traffic's allowed in. And then on the outbound side, it's allowing all traffic out, and then you have this other rule that's denying all traffic out. The first rule takes precedence. But if you thought you were going to get fancy and you were going to say only allow port 80 in and then deny everything out, nobody would be able to get to your website because you would see the traffic coming into your website, but the reply from the website would get blocked. So be aware of that if you get to a point where you're doing this. People find that these network ACLs are very handy if you need to block somebody across the board. Maybe somebody is probing your network, or you're detecting something that's causing a problem. Without having to go into your individual security groups, you can block them across your whole VPC. Fred, did you still have a question?
Yeah, I thought the way inbound works is that in terms of like a website or something like that, if you have an inbound open port on your server, anything can connect to that, but the server can still send messages over that inbound pipe, not necessarily go through the outbound pipe.
That may be true with WebSockets, but it's not true with most traditional TCP traffic. I don't know because I don't have WebSocket experience. My gut tells me that it's going to be the same, and you're going to have this range of ports that you have to allow, sort of their what they call the higher range, like 1024 to 65,000, 65535, whatever that higher end is. But let's check that out because we can certainly clear that up in Slack if that's wrong. Any other questions? Otherwise, we're going to move on. Quick tip. I'll post these slides out in Slack because they do have links to the different resources if you want to read up on VPCs, subnets, or any of these other tips that I post. If you do have a lot of traffic on your AWS account, there's an awesome blog post on AWS that walks you through how to turn on flow logs, which are essentially a log of every single time traffic goes in or out of your account. It doesn't record the payload. So, I mean, if you're serving up video content, you're serving up terabytes of data, you're not going to fill up a log with terabytes of data. But if somebody's made 1 million connections and each connection had 100 bytes of data, maybe a source address and a destination address and the time of the event and things like that, that 100 bytes of data for a million records, that'd be 100 million bytes or 100 meg worth of data. So it's not an unreasonable amount of data to store, but their post talks about how to visualize that data, and it'll break it down and show you sort of where it's coming from, where it's going to, what kind of traffic you're seeing, and that's based on existing AWS services that you can spin up very easily without any third parties. So now moving on to internet gateways. Now that we've gone through, we're just working our way up with the building blocks. We've talked about the network that comes with your account and situations where you might add additional networks or segment those networks with subnets, and we've talked about how some of these firewall rules work with the subnet groups and the ACL rules. But now I want to talk about these gateways, the internet gateways and the NAT gateways. How many of you have ever heard of these terms? It's not as common enough to mess with, so I'm impressed that so many have heard of it. By default, when you set up an account, your VPC is going to have an internet gateway. That's something that Amazon provides. It's fault tolerant, and it allows traffic to come in and into your network and go out of your network. It's basically their routing infrastructure. And those gateways, I believe, are what host the different firewall rules we were just talking about. But there's a pretty big difference between the internet gateway and the NAT gateway. I mentioned that the internet gateway is provided by default and allows inbound and outbound traffic, meaning that you can map public IP addresses to your server instances and people can access those from the outside, whereas the NAT gateway only allows outbound traffic. We talked about having your database servers on another subnet that's not internet facing. That private subnet wouldn't necessarily need internet access. But what happens when a software update comes out for MySQL or for Postgres or whatever stack that you're using, or the OS that it's running on? I mean, if you don't have internet access, those patches are never going to get applied. Now, granted, if you're in a very sophisticated AWS environment, you're most likely pushing the patches to your image for your server, and then you're rolling out a new image with the patches on it. And so there wouldn't be a need for internet access in some really advanced cases. But most of us mere AWS mortals aren't to that level, and we're letting our servers patch themselves. And so with that being said, if you have any type of resources on a private subnet, you're going to need to fire up some sort of router or Amazon's NAT gateway that will allow those systems or those resources to talk to the internet. Much like the router that you have at home for your internet, that's a NAT gateway for your house. It's either built into your ISP's modem, cable or DSL or otherwise, or it could be a separate box, but it allows everything inside your network to talk to the outside and theoretically nothing on the outside to come in. I say that because, I mean, there are always workarounds, but for the most part, that's true. And Be aware though, if you're needing to connect things in those private networks to the internet, and you do roll out NAT gateway, they're going to charge you an hourly fee to host that NAT gateway, because that is a resource in your account at that point. And let's say we go back to where we had a subnet A in one data center and subnet B in another data center, and both of those were running sort of your web stack and your database stack. If your databases in A and B were sharing one NAT gateway, that you have to choose where you're going to put that gateway. They could certainly share a gateway in A, meaning that it's over here in this data center. And as far as running updates, latency isn't necessarily an issue, because you don't really care if it takes an extra few milliseconds to download some updates. But if A goes down, and your NAT gateway was in A, if that whole facility goes offline for some reason, your database server in B is no longer going to be able to get up to the outside. So they're going to tell you, in that case, you're going to want a NAT gateway over here on network A and over here on network B. But that's twice the price, because that's twice as many NAT gateways. So do be aware of that. Some people will spin up really tiny instances and run their own NAT gateways. If it really is just a matter of connectivity to the outside for updates, that's probably appropriate, because if something were to go wrong, or you went to maybe install updates on that gateway and it were unavailable for a few seconds during a reboot, it's not going to really affect those servers that only occasionally need to get to the outside. So that's certainly an appropriate way to go. If you look at the pricing of a NAT gateway versus the pricing of Amazon's smallest instances, which used to be T2s, but are now the ARM series instances, you can run roll your own NAT box on those, basically. And there are tons of blogs out there that talk about this, because it's a very common practice. And then you can have those database servers or whatever's out in your private networks routed through those instead of through Amazon's NAT gateway at a fraction of the price. Just know that it's not managed, so yes, it's less expensive, but now the burden is on you to keep that up to date and keep it online and such. So again, common practice, but if you had systems on the inside that maybe needed to get out and query data, like let's say you had some sort of working workers, that's the thing that they would do, right? But some sort of queue-based system where you're throwing jobs into a queue, and then you have these things that are working on the jobs. They don't need to be internet facing, but they need to get out to the internet, maybe to send emails, maybe to pull in data, whatever that is. If that's mission critical, make sure that you either have a really robust do-it-yourself infrastructure, or that would be a really good use case of the managed NAT gateways, just because they do such a good job keeping those online and available. Any questions about gateways before we move on? Yeah.
What level is the internet gateway on, or can it be at different levels, the subnet level or the VPC level?
The internet gateway is at the VPC level, I believe. I'm almost sure it is, but now I'm doubting myself. Yeah, I'm almost sure it is. And we can look. I'll show you where to check, and then we'll both know. If you go to your VPC and you drill down, it should show, it shows the ACL here, it shows the routing table. So my guess is the routing table. Does it? Okay. So internet gateway, let's see what subnet it is on. That would make sense. I was under the impression it was redundant. And I'm almost sure. I'm going to backpedal and say it is tied to your VPC. It's not tied to a subnet. I mean, certainly it's probably connected to each subnet or certain subnets, but a benefit of using this particular managed service is that it is spread across subnets. So you don't have to have multiple internet gateways, if maybe that's where that question was going. Any other questions? That was a great question. We'll keep it rolling. If you think of anything, let me know. Because
What about routing tables?
I didn't dig into that because most people don't usually have to touch that, but that is at the VPC level. So when you look at your VPC, you'll see down here, you'll see the route table assigned to that VPC, and then you'll see a list of routes. And the routing table is something that you would dig into if, um, let's say you have servers or these worker type instances on a private network, but they need to be able to access data on S3. Normally, or originally, when they first launched S3, you would have to go out to the internet to get to S3. It's just, I mean, it's an internet service. Even though it was within Amazon, it wasn't accessible in your private network. But nowadays, you can edit your routes, and you can add a target, such as a. I will have to get back with you on that, but without being in an account that has this offhand, you can basically add a target where you can say, this service is linked to this VPC, and so maybe that's not routing, maybe that happens in something else. If anybody, that's under endpoints probably. You would create an endpoint, so it's probably tied to routing, but it happens behind the scenes. So it's on a little bit of an aside, but while we're here, if you do have services on private networks and they don't have a way to get to the internet, or you don't want them to access services like S3 over the internet, you can basically create an endpoint within your network that they can connect to, so that they never have to go out that internet gateway. They go through this endpoint instead. And that gives you some flexibility in terms of when you're setting up your service, not service groups, what am I saying here? Yeah, security groups. You can lock that down so that certain services can access those endpoints. I know that's an aside from your question, but did I answer your question-ish?
Yeah.
Okay. Let's move on to EC2 network interfaces on IP addresses. I'm assuming, does anybody here know what an IP address is? Okay, a few of you. I'm assuming everybody does. But any of your resources are going to be tied to some sort of IP address. There are public IP addresses and private IP addresses. A lot of people will be surprised to find that when they're working with EC2 instances, all of them are assigned a private IP address. It's only when you introduce the internet gateway that it's mapped to a public address. And the public address isn't even on the server. So when you're looking at your server settings, let's say you're running some sort of tool that shows what are the IP addresses on my server, it has no idea that you have a public IP address, because it has a network interface, and then it has an IP address bound to that that's private. And the only reason that you have a public address is on the outside of the internet gateway, Amazon's allocated you a public IP address that anybody in the world can ping or connect to, assuming your rules allow it. And then that address is mapped directly to a specific private IP address or a specific instance or resource. I mean, you might not realize it's mapped to a private IP address. You just know, I want this public IP address to go here. Or when you fire up an EC2 instance, a virtual server, you'll have the option of saying, no, I don't want a public IP address, or yes, I do. If you say no, that mapping doesn't ever happen. And so even if you're on a quote unquote public subnet, that server is technically unreachable. A lot of people will start there thinking that the server is safe. But but when you say, yes, I do want it to be accessible from the outside internet, that's when Amazon they'll have a huge list of IP addresses, and they'll just find one nobody's using, and they'll link it to your service and say, this is your public address. But behind the scenes, what's happening is when traffic hits that public IP address, it's forwarded through the internet gateway to that instance. And the reason that's important to know is some people run services that have to have a public IP address, and because of the way they do the mapping, most of the time it's sufficient. Most of the time you can get away with their setup where there's a private IP address and then there's a separate public address that maps to it. But it's something to be aware of if you're troubleshooting, just because most people don't realize the way those things map together. And then to go one step further with the public IP addresses, every time you shut down your EC2 instance, let's say you have a test server that you fire up for a few hours and then you shut it down for the weekend. When you turn it back on, by default, you're going to get a new IP address. Depending on your situation, that might be fine, but most people, if it's part of a cluster or some sort of public-facing service where you've mapped a DNS name to it, which we'll talk about here in a little bit, but let's say www.acme.co, and that's supposed to go to this IP address. If let's say your server crashed and it went offline, it wasn't even an intentional thing, and then Amazon brought up a new server, most likely that server is going to come up with a different IP address. So what they've offered are these elastic IP addresses, and those are addresses that you can allocate to your account, and they'll always be in your account as long as you're willing to pay for them. And there are two ways to pay. You can either pay for them by linking them to an EC2 instance, and you're paying those instance fees, and then it's basically complimentary, or you can pay an hourly fee for it to be available there, which most of the time, realistically, if it's an IP address you're using and you're needing, you're more than happy to pay the however many cents for it to be in your account that hour that the server was down, so that when that server comes back online, it can bind to the same IP address it was on before. But do be aware that they charge you for those elastic addresses that you pull into your account when you're not using them. Don't just go willy-nilly thinking, well, I'm shutting down this server, but I might use that address in a few months. You're paying the equivalent of what they would charge for their smallest server. It's not a lot, but it's not free. As far as when to use elastic IP, how many of you have heard of elastic IP addresses or were aware that there was a difference? Okay, about half. As far as times to use elastic IPs, for those who aren't aware of them, I keep going back to a web server, but a more realistic example might be an email server or some other application server that has to be public facing that can't be routed through their application load balancer or something like that, because realistically your web servers, you wouldn't ever worry about assigning an elastic IP address to them. If you're doing that now, I'd love to chat with you afterwards and just talk about some other things that we're not going to cover today, but because there are better ways to approach that are super affordable, so that you have some extra layers of protection and convenience. But let's see. Oh, before I move away from IP addresses, a very cool feature that a lot of people don't know about is that if you do a reverse lookup on an IP address, it'll show you a host name, which is very common. Most people might know that. So, for example, if I'm browsing to a Google website and I look to see what their server IP address is, and I do a reverse lookup, it'll say like www.something.1e100.net or whatever their domain is behind the scenes. With Amazon, you see the same type of deal where you can do a reverse lookup on an IP address and you'll get a host name. And that host name is special because if I try to ping that host name from our office, which doesn't have any special connection to Amazon, that host name is going to resolve to the public IP address. But the magic part is if I'm inside my network and so I'm in my Amazon, in whatever network that resource is in, and I ping that public host name, I'm going to get the private IP address. And the reason that that's really, really cool is because, at least for us with some of our services, we'll have an extra layer of DNS where we might, instead of mapping www.something, and I go back to that, that's a bad example, but let's go with the web server. Let's say instead of mapping www.acme.co to an IP address, I map it to that host name. Anytime I'm accessing services on that server from the outside, it goes to the public address. But anytime I'm accessing them from within my account, it goes to the private address, which simplifies some of your rule sets and can potentially keep your traffic costs down because it's considered internal traffic and not internet traffic. And then to keep things on track, I'm not going to talk much about IPv4 versus IPv6, other than When we first started hosting in 2001, we were super excited about IPv6. I'm still super excited about IPv6. Think it's going to make it. It'll get here soon enough. I mean, realistically, your phones and such are starting to, or have for a while had native IPv6 addresses. But when any of us are hosting on Amazon, by default, most of our resources are only going to have an IPv4 address. They've gotten to a point where you can bind IPv6 addresses to some of your resources. My personal recommendation after hosting things on dual stack for over a decade is that if you are interested in dual stack, push that out to the edge. Have your application load balancer or have CloudFront handling the dual stack for you. And then when they're routing traffic into your application servers, have that go over v4. The problem that you run into is if you're accepting traffic over both stacks, you need to make sure that your rules are perfectly in sync all of the time so that you're allowing, say, port 443 to this IPv4 address and to this IPv6 address. And the second those get out of whack and like 20% of your customers call with an issue that nobody can figure out, you're going to be ready to get rid of dual stack too, at least internally. So now on to DNS. How many of you have managed DNS or registered domain names ever? Okay, pretty much everybody. So when it took us a while after we moved to AWS to be sold on Route 53, their DNS service, because they do charge a per zone per month fee, and we, with the background being a hosting company, had perfectly good sets of DNS servers all over the place that we could load up our zones on. And so we left them in our hosting platform for a long, long time. And then we started to run into little things where I thought, well, they make it sound like that would be really nice. Maybe I should move a zone over and just see what this is all about. So with that being said, right off the bat, if you're going to move a zone over to Amazon, you certainly have the option to move the domain name over. That was the last thing on our mind. I was concerned about vendor lock-in. I didn't want to have to deal with moving things in, having an issue moving things out. Get a little bit ahead of myself here because that followed later, but I'm not going to touch on registering domain names a whole lot, so I'll say it now. Transferring domain names into Amazon has been very pain-free. We've transferred domain names out of Amazon. It's also been very pain-free. The interface for handling all of that is super automated and runs through your account in such a way that you're not having to wait on anybody else, and there aren't huge delays. So I was super impressed with that. And being a hosting company and having a wholesale domain platform access for years and years and years, I am also going to say kudos to them on keeping their domain name prices low. I mean, that's sort of been a common theme with any of their services, but I figured if there was a place they might botch it, it might be domain names, and they've been super competitive. So if you do get to a point where you're hosting domains and zones and DNS records in Route 53, probably would make sense to move those domain names over. It does simplify some things. But the huge benefits for us of having some of our zones in Route 53, and now we've just moved all of them for simplicity's sake, is that there are certain types of records that standard DNS doesn't do well with. For example, if you want to point www.acme.co and just the bare acme.co to a web server, the bare address without www technically has to be pointed to an IP address. It can't be pointed to a name or a CNAME record. And Amazon, and that the reason that's important is from a management point of view, a lot of these services like your load balancers and your CloudFront, they don't give you an IP address. They're distributed by nature, and so they want you to point to a name. If you point to an IP address, you're just sort of shooting yourself in the foot, because the second that particular node of their cluster is offline, nobody can get to your website through just the acmeco.com. They'd have to go to www at that point, assuming www.acmeco is pointed to a host name. If it was also pointed to that IP address, you're in the same boat. But more and more of these web things are distributed in nature to where you have to point to a host name. So when you're setting up the records in Route 53, and similar options are available in other DNS providers. I'm not saying that this is only available in Route 53, but they have the ability for you to choose a special alias record. It's a record type instead of an A record or a C name or an MX or any of the others you might have ever seen. And then when you choose that special type, it provides a drop-down list of resources in your Amazon account that you can point that to. And so behind the scenes, they'll automatically take care of the mappings. And I believe what is happening is they're serving up A records or IP addresses, but they're doing that at random or round robin in such a way that they're getting rotated through the different nodes of their CDN or the different nodes of the web balancer. And then if a node goes down, they'll stop serving that IP. They take care of all of that for you. So that's a super magic thing that a lot of people might not be aware of. Like I said in the slide, the alias record could point to the load balancer or to CloudFront. I also mentioned the Apex record issue, your sort of bare domain name. And then one more feature I wanted to talk about with Route 53 is that they support health checks. And what that means is you can basically set up a check in such a way that it can look to maybe a web service or some other server, and if it gets a certain type of response, let's use a web service as an example. You can say check these IP addresses for our primary web server or web service or what have you, and if you're getting an error message, then if everything's okay, return that IP address. I want to send people there. But if everything's not okay, like let's say that web server is returning a 403 or a 404 or 500, something other than a 200 range code, then I want to send this other IP address. So like MSU, for example, they have this set up to where if their primary web servers go down in some sort of an emergency, the Amazon health checks will automatically detect that either the server is not responding or it's not sending back a 200 error code, and Route 53 will reply with sort of their backup failover servers that have their emergency data on them, so that you can see like MSU emergency status. That would be a practical use case of these health checks. Any questions about Route 53? I feel like I'm breezing through pretty quick. Yeah, Fred? Because there's just so much more to it than I've covered.
If Route 53 is also a registrar, do they offer any discounts on registering domains through them?
I would consider their rates wholesale rates. There isn't a discount per se, it's just the rate. So if you register a domain name through them, all of those rates are published. You can find them online or in your account, and they vary by top level domain. So a .com and a .co might be two different prices, but that's just based on whatever the provider of that top level domain is charging plus some sort of markup.
And then also, if I want to so I can also transfer domains to Route 53 as well?
Absolutely. Yeah, and they make that pretty pain-free. Now, I can't say as much on the other side. Wherever you're transferring from can sometimes be a burden. I mean, we've seen so many transfer ins and transfer outs over the years that I know when I see some hosts like, oh, this will be easy, and then there are others where I know I need to assign somebody to babysit the transfer, or else they're going to basically try to keep the domain from ever leaving. So if there's a burden with the domain transfer, it's generally on the losing side. Yeah, good question though. Getting close to the end. Yes, because the next slide is Q&A. So we're getting really close to the Pat and Alley time, if anybody's wanting to do that. But I do want to talk about load balancers and target groups and SSL certs. Those all go hand in hand, at least the way I'm going to approach this. I also thought about talking about Cloudflare, the CDN, but I gave an hour talk on that probably within the last year. So if you're interested in CloudFront and even serving up content from an S3 bucket over CloudFront, check out that talk. It walks through it. It has some code samples, but I'm also glad to chit chat about things like that afterwards. But back to load balancers, there are 3 different types of elastic load balancers. The Amazon offers application load balancers, network load balancers, and classic load balancers. So when you go to set up a load balancer, it's going to give you those three choices. For those who aren't familiar with, how many of you have rolled out any type of Amazon load balancer? Okay, a few of you. How many of you are familiar with the load balancer concept? Okay, most of you. So, like most load balancers, the idea is that you point a host name to their managed host name, and then they're sending traffic to the different nodes of the load balancer, and then those nodes are forwarding traffic into multiple nodes of your application tier. So let's say it's a web application with the database again, and let's say your web servers are stateless, so that you can scale them up from, maybe you have 3 running at any given time, but you can scale up into the tens or hundreds if you need to. That application load balancer, for example, is going to accept web requests, and then it's going to forward them in to your different web servers, all the while checking the status of those web servers to make sure that they're all healthy. And if it ever detects a problem with a web server, it stops sending traffic to the server. So by them managing their sort of cluster of load balancer nodes, people on the internet can always get to the load balancer, and then by them monitoring your sort of web-facing tier and figuring out which web servers are healthy, those load balancers can always send traffic on to the web servers. Now, the network load balancers and classic load balancers have some specific use cases. I'd say 90% of the time, since most of us work on web projects, we're going to be interested in the application load balancers, which are specific to web content. So I'm not going to dig too much into the others, except to say if you have some sort of special protocol, like a TCP protocol that isn't web type protocol, you would look to these others. Classic is sort of going by the wayside. It's been replaced by application and network, so when you go in to create something, it'll be sort of grayed out. But for people who rely on that for any reason, it is still available. So with application load balancers, I just wanted to describe a little bit about how they work, because if you've never worked with them, they seem a little bit intimidating, quite the mystery, like how much is this going to cost? How do I even set it up? There is a fee to application load balancers. I want to say the base fee isn't cheap either. I mean, when you're used to paying pennies here and pennies there, I want to say it's in the $10 to $20 a month range. So it's not outrageous, but it's not free. And so with that being said, when you go to set it up, and I'll go into the console if we have time and show you the different pieces, but you start to set up the application load balancer, and you're able to bind an SSL certificate to it. So normally, if you've ever set up web servers, maybe you've used Let's Encrypt, or maybe you've gone and purchased an SSL certificate and installed it on the web server, this is one of the huge perks, in my opinion, of using an application load balancer. They'll manage that SSL certificate, they'll manage the renewals, they'll terminate the certificate, or they'll terminate the SSL connection, meaning when some inbound request is coming over SSL, it's SSL to the load balancer, but then it doesn't have to be SSL to your web server. It's very common practice for people to just have HTTP or unencrypted traffic from the load balancer to the web server, because in theory all of that is riding over your own private network and is very low risk. Again, going to the very beginning where we talked about moving things into different subnets and different networks, that would be a perfect example of why you'd want to make sure you didn't have a whole bunch of crap or garbage in one big network. Because if you have maybe your web servers and your database servers and some other servers that you thought you needed and then stopped updating, and they're all in one network, and somebody hacks into one of these other servers, they're on that network where that unencrypted traffic is flowing through, and that could potentially be a risk. But by segmenting everything to where your different subnets or your different networks only have web servers or certain types of traffic, and don't have all of this dev stuff sitting around. Again, another reason to have a whole separate account for all the dev stuff, because you know how we can sort of roll things out and then have them simmer for a while. But by having a nice clean network, perfectly common for people to have that load balancer traffic go directly to the web server without any SSL encryption at all. And that reduces overhead on your web servers, because SSL is encryption, and encryption takes CPU. And so if you're already facing CPU issues, you've got a lot of traffic, and you're having to scale up servers because they're getting too busy. If you're able to push that SSL portion of your server load off onto a load balancer, you'll see some savings in terms of processor performance, and you won't have to scale up quite as much. I mean, it's probably minimal, but it's enough that it'll be measurable. And another thing that is really exciting about application load balancers is that, sorry, I was gonna grab a water, I'm like, they have a thing called Web Application Firewall. And how many of you have ever heard of that? Okay, how many of you have used that? Okay, not everybody, a couple of you. So if you have an application load balancer, you can take advantage of this service. And I'm not going to dig deep into what it is, but I do want people to be aware of it, because you can set up rules, or you can enable rules or choose rules that you want to leverage that either Amazon has already provided, or custom rules that you set up that will help protect the traffic or filter the traffic before it ever gets to your web server. So it's another duty happening on the load balancer, and a very specific rule set that is a great one to start with is the SQL injection protection. If you have a web server with some custom code, maybe not the latest greatest framework with all of those protections in place, and you're a little nervous about your SQL injection exposure, that could be a good thing to have some cheap insurance until you can resolve those issues. Nonetheless, I mean, even modern frameworks can end up with SQL injection issues. It's not impossible for that to show up in modern software, but it's a lot less likely the way it's engineered now. But you can turn that on. There is a fee for web application firewalls, or WAF, as they call it, but it's something to be aware of. And yet another reason to not have your web traffic go directly to your servers. And so when you're setting up your load balancer, there are a couple pieces to that. You're going to have your listeners, and your listener might be port 80, might be port 443, might be both. And then you're going to have target groups. And let's say you have a web tier with 3 servers that scale up. That's going to be a group, and that's so when you're defining your target group, usually that's something that's defined as part of your scaling. But you end up, your load balancer ends up mapping that listener to that target group, and you'll say, I want port 80 over here to go to this group, and then anytime that group is scaling up and down, it's automatically, the new node is automatically registering in the target group and saying, I'm here, you can start to send me traffic. Or the load balancer, as it's checking those servers, if it realizes a node is gone, it just maybe died, it will take it out of the target group for you. So that's all managed automatically. So it comes into the listener, goes out to the target group, and the SSL traffic only came to the listener and stopped, and then it was normal HTTP traffic on behind that. And with the SSL side of things, this is a perk of having your domain in Route 53, but they have the ability for you to basically set up a single-click SSL certificate. You can type in the host name that you're wanting to be able to serve up on your load balancer. I mean, there's an extra few steps. So it'll take you over to the SSL area, but you'll enter the host name or host names that you want that website to be available on. And if those domains, or if those host names are part of a domain that's in Route 53, it can go in and pretty automatically allocate and approve that. Whereas normally, if you've ever purchased SSL certificates, you usually have to go through some sort of email verification, or things more complicated than that sometimes. This is all automated. It's a lot more like Let's Encrypt, where it just happens. So that's a bonus. And you can do that without Route 53, but it takes extra steps.
Yeah, okay, yeah.
Mm-hmm.
It's only that easy with Route 53. But
Yeah.
otherwise,
There are,
it's DNS records. Which
you can add DNS records. Absolutely. You can go in and the question is, can you only do that with Route 53? No, they'll have an option if you don't have your records in Route 53. They'll give you 2 or 3 different paths to choose from. So they're all fairly simple, but they do take time. So if you're having to do a lot of this, it can be a pain. But Miranda's right. If you go in and create the DNS records that they're suggesting, they'll be able to continue to renew the SSL certificate for you.
You do wildcard.
You can. Yes, you can do wildcard certificates as well. And the other cool thing that a lot of people don't realize is that you can host multiple websites on a single load balancer. You can host multiple web SSL certificates on a single load balancer. They don't have to be all 10 names on one SSL certificate. You can literally bind the different certs and it works out. And that may only be, there may be a caveat to that.
It's
But
25, a limit of 25 SSL.
okay, so there is a
If
limit.
you have more than that, then you do have to bind them together.
Or
But, I mean,
roll,
you
yeah.
can basically have as many as you want.
There you go. And AWS Pro right there with 25 sites on a load balancer before they topped it out. And
Squeezing it for all.
yeah, but the point of all of that is if you're looking at that $10 to $20 a month cost, don't think that you're having to pay that for every single website. The takeaway there should be if you're managing 2, 5, 10 different sites, all of those could be piped through that load balancer. And if you're managing API gateways, you can leverage some of this as well. But I'm not going to get into the API gateways because that's a whole nother beast. With that, I know I heard some clapping, so I think other people are wrapping up. Any questions? And I'm going to stick around for a little bit and clean up, so you're welcome to come and ask questions even if they're off topic. I'm glad to help out. You're also welcome to ask questions in Slack afterwards. So if you think of something later or you're looking at something and you have a question, hopefully I or somebody else in the channel can pipe up and help you out. But thank you everybody for coming out. Hopefully this was helpful, and hopefully now you can be networking gurus too. So thank you much. Yay.